All right, quantitative data has four major ways you summarize it. Four major ways you summarize it. Two of these ways are the most popular, but there are four major ways. One is by summarizing using measures or techniques for central tendency. Measures of central tendency. The next one is measures of dispersion, otherwise measures of variability. Third is measures of relative position, otherwise called quantiles. And the final one, quantiles or percentiles. So you can put those two side by side, relative position, quantiles or percentiles. And then measures of distribution of the shape, the skewness and the kurtosis. I will explain what that means as we go along. Just take note of that for now. So let's look at measures of central tendency. I'll come back to this one, but let's just look at measures of central tendency. Three major ways central tendency is measures of central tendency, three major values: mean, mode, yeah. I'm sure we have heard of this over and over again. Mean, mode, median. Mean is the average. We add up the values of the variable from individuals, units in the sample, and you divide it by the total number of individual units. Mean height, for example, is keep a record of all the people whose heights you are interested in studying. You record down all their heights. You count the number of people in that sample. So for example, let's assume there are 20 in that sample. I've found the 20 of them. You got different heights in meters. You got different heights in meters from these people. There are 20 of them. So once you say mean height, you would have added up all the values for height in that class and divided by 20. That's what this N means, the sample, the size of the sample. This thing that looks like, I think it looks like an E, but it's not exactly an E. It's the summation sign. No, it's a summation sign. So whenever you see this, it looks like you're adding up. So this is adding up. X is the value representation of the individual value. X. So X for me, when I'm talking about height, it be 1.5 meter. While X for Precious may be 1.7 meters, and so on and so forth. So summation XI, which means that each individual has their X. The summation of that divided by the total sample size, that gives you your mean. Median is the number in the middle, the middle ranking number. All right, sorry about that. So the middle ranking number, which means that you have to rank. And ranking means you will arrange the numbers from the smallest to the largest, or from the largest to the smallest. So that is, you're going to rank. And the one that happens to be the middle number, which is identified by n plus 1 divided by 2, where n is the sample size. Number of participants in your study is your N, number for number. And then so the total number of persons. So example, there are 20. There are 20 in this class from the last one we did, when we had to calculate mean. And 20 in this class because we used as denominator. So in this case, you have N plus 1 divided by 2. So that is 10.5. So the middle, when you rank all the numbers in that data set from the smallest height to the shortest to the tallest, there will be a number, there will be a try to identify that 10th number. And then you also identify the 11th number. So your median lies between number 10 and 11. And then of course there's something you can do about it. You add up at the value for 10 plus with the value for 11 and divide by 2. Mode, most frequently occurring number. Most frequently occurring number. So if the value of a particular variable may occur more than once in the distribution. It's a distribution. So each of these have their advantages and disadvantages. Simple to calculate. So we're talking about the mean. It's simple, easy to calculate. It's very useful in a lot of other statistical analysis and calculations. It is really representative of the population because you are studying the entire, you're studying, I mean, it's representative because all the values are there. So you are involving, your calculation involves all the values. You can't take one and leave the others, the way median and mode does. This one involves all the values. So mean is actually quite very, very, very good at presenting the population. Right, so that's advantage. Disadvantage is what you can see. Non-statisticians find it a bit difficult to understand the concept of the mean. Mean value may not always represent the actual scores. And it's affected. The major thing here is that extreme values mess up your mean. So for example, remember the issue of central tendency. You still have somebody whose height, we're talking about height of people in class, somebody whose height is 2-point-something meters, double. It will push, because once you add 2-point-something meters to the entire equation, we're trying to find what's the mean age. It was the mean height value. A very high value will push your mean, to push it to one corner. Either skew it to the right or skew to the left. Median, also very easy to calculate. It's important we bring in median when we now have extreme values, or we bring in median when the population, the distribution in the population does not follow the normal distribution curve. And at some point, we will learn about the normal distribution, or what's called the Gaussian curve. Of course, it just picks up 1 or 2 numbers and works with them. So no dealings or relationship with all the others. So it may not truly be representative. Mode, the last in the series of 3. Very easy for you to calculate mode. But mode is not always representative of the population because you do not use the entire set of values. But the advantages are have extreme values. You can neither skew more to the left or to the right. It's relatively easy to calculate. Okay, so let's take questions. Mm.